Hello everyone, my name is Wilfred Abidjan. I am a plant breeder. Today I'm excited to share with you some information. Keep tuned, subscribe.
We are going to run analysis of variance in R. After setting a working directory, we load data. Our data is barleyyield.csv. I like giving the name my data, then we use read.csv. Then we run. Now let's view this data. We can view this data. You can see that it has 2 replications, and each replication has 4 varieties. And this experiment runs in 3 locations, and yes, we get to see that. Then after that, let's see the structure of this data we are working on. You use str, then you write my data to get structure of this data. You can see that in the console, yield is a number, location, variety, and rep are not factors. We will like rep, variety, location to be factors, but yield to remain numbers. So what we do, we change rep, variety, location to be factors. To change that, we specify the column that we want to change. We write my data. Let's start with variety. We write my data. This $sign, then variety means we are selecting the variety column. We use as.factor to change this into factor. Then into brackets. Then you write again the column that you want to change. So we have written the column that we want to change. Then we put this sign. Then as.factor. Then the column that we want to change, but now you put it into brackets. Then after that, we run. It has been executed. You can see down here in the console. Then we do the same for location. You write my data location, this the column that we want to change. This column location is in the file called my data. Then as.factor, then the column that you want to change. You run. Then my data and column for rep, as.factor, then my data column rep, then you run. After that, let's now see the structure of the new data. str my data. Now you can see down here in the console, location is a factor, variety is a factor, replication or rep is a factor. That's very nice. Next thing we do, we install packages that we are going to use to run ANOVA. We are going to install a package called mp4 and lmer test. So you write install.package, then into brackets lme4 with this quotation, then you run for it to install. It has installed. That's why you find in the console mine is called mine coming install.ok. Oh yes, it is installing. I thought it was there. Yeah, it is installing. That's why you see it's running here and some red writings in the console. Let it install. When it is installing, in the console, in the right side of the console, you see a red sign here, means it is installing. After it has gone off, it means it has finished installing. Let's do the same for lmer test. Install.packages lmer test. We run, and you see in the console it is installing. It has finished. Now let's load them. We write library lme4. We load it. It's loading. Let me repeat it so that I see a blue writing down there. Yes. Let me load lmer test. Let me repeat it so that I see it. Good. It has been loaded. Okay, when you load, and if it writes itself down here in blue, you know it has been loaded. So let's do our ANOVA. We are going to use AOV command. AOV stands for Analysis of Variance, but using AOV will treat all this variable as fixed effects. So you write any name which you want to give your calculation. Mine, I've written M, just I've given it a letter M. Then I've written AOV, which stands for Analysis of Variance, and we are going to run all these variables as fixed effects. Then you write your explanatory variable, which is yield, which is a continuous explanatory variable. Yield, then you write this line. It's going to explain our factors, variety plus location, plus the interaction between a variety and a location. We write interaction with this colon here. Variety colon location means it's the interaction of variety and location. Then you put comma, you write the source of your data. Data is my data. After that, you click there, then you run. It has run. To see the ANOVA table, you write summary into brackets M. M is our calculation. Now we want to see ANOVA table, summary M. Then when we run, in the console you can see this is our ANOVA table. Variety is significant and the location, but the interaction between location and variety is not significant. That is it. You can do the same. Instead of writing on this, you write your explanatory variable, then this, then you write variety star location. That's variety times location. When you write this, it means it will give you the mean squares for variety, location, and interaction of variety and location. Then you specify your data. Just write the same analysis of variance, yield, which is our explanatory variable, variety times location, so that it gives you variety, location, and also interaction. If we run this and write summary of M1, because we had given that this is M1, you'll see that it is the same. You see this table and this table, it is the same. So it depends on how you like it, what's easier to grasp. Now let's look at linear mixed model. This is where we have random and fixed effects in one model. In linear mixed models, we use LMER. So let's give it this calculation results 1 and use this command LMER. Then we write yield, our explanatory variable, then this sign here. Then we write our factors. This is variety is our factor. We have put it into brackets because it is a fixed factor. But location is a random factor, and that's why we have put 1 and this sign. This here means that location is a random factor. It will treat location as a random factor. Then we specify our data. Data is my data. If we run this, to see ANOVA, you write ANOVA into brackets results 1. Results 1 is this model that we run. Then this model results 1, we run ANOVA. ANOVA results 1. Then if we run, you can see there's a table, ANOVA table which has come here. It has only shown variety. Variety is our fixed effect, and it has shown that variety is significantly different. But now, to see our random factor, we use the rand command. Rand command is a command which is an LMER test, which shows the ANOVA of random factors. You write rand, then results 1. If we run, you'll see that location has come here. It's a random factor, and this is a probability of 0.14, and it's not significant. That's all for today. Now you can do ANOVA using linear mixed model that has both fixed and random effects. Thank you very much.